and then we have a power series representation over here. So we have to we are given the power series representation of the derivative, so we have to find the power series representation of the derivative of the function. So we have this. Now I've made a video on how to represent functions in power series, so you can check the description. The link of the video will be there. Then also you wait at the end of the video, you see it on your screen, so you can check how to represent power series, the functions in power series representation. So we have g of x being equal to 5x divided by 1 minus 3x to the power 5. So we have to represent give the power series representation of the derivative of the function. So we have f of x being equal to 5x here, then divided by 1 minus 3x to the power 5. So we have to represent this in a power series. So before we do that, in the first step, normally I do it in 3 steps. So the first step, we must represent it in this form. We must get this series in this form. So we have to compare this. Now getting this series in this form, then which means that we have to factorize 5x out. So factorize 5x out, we have 1 here minus 3, then x to the power 5. So now our series is in this form. Now the second step is that we have to identify these values a and r, and if you're looking at the function over here, a is just 1, then r we have here as r here as 3s to the power 5 And the third thing we are going to do is that we are going to represent the series in terms of a geometric sum of a geometric sequence, which is ar then to the power n so infinity then to 0. Or the second option is that we can represent it from that, but it is going to start from 1, so that I can have ar minus 1, but normally I prefer this, so you can use this. So let's represent this series in terms of this. So therefore we have g of x being equal to, now we have 5x out, so we can bring the 5x out so that we can have infinity then to 0. A is just 1, so we have 1 here, then r is just 3x to the power 5, then n over here. Now with this series we have g of x here being equal to, now we have 5x here, so we bring it back there. So we have infinity going to 0, then we have 5x here, then we can have 3 to the power n, then also 5 to the power 5n, right? So it's affecting both of them. So 3 to the power n, then multiplied by x to the power 5, then n. So this is just how to represent it in the how to represent the function in the power series representation. So we have this. Now the next thing, the question says that we should find the derivative of the function. So now if we have represented it in a power series, then we have to find the derivative of g, which means that the d over dx of the summation starting from infinity then to 0, then we have 5x here, then 3n, we have 5n here. So we have to find the derivative of this. So let's do that. So therefore g of x will just be equal to, now what we are going to do is that we are going to differentiate this. But now if you look at the values over, we have x here and we have x here, so it looks like a product of two values. So look at what I'm going to do. So let's do it this way. So we're going to infinity then to 0, so that we can have 5 here, we can have 3 here, then we can have x to the power 5n, then we add this s to it so that we can add plus 1. So now we have only that, and this remains constant because we are differentiating with respect to x. So then from here we can have g of x being equal to summation of that. Then we have 5 here. Now differentiating this, we first differentiate what is at the top there. So differentiating what is at the top there with respect to n, then we are getting something like so we are differentiating with respect to x, so we have this. So now there's no x here, so we just bring the whole thing down here. Then we differentiate x. So differentiating x, now since we brought it down, we just subtract 1 from it. So subtracting 1 from it, then we have x to the power 5n. Then we subtract 1 from it, then 3 to the power n. So therefore we have the summation infinity here, n going to 0. Then we have 5 to the power that, then 3 to the power n. And basically this is the derivative of the power series. So thank you very much for joining me in this section, and I hope this section was also fruitful. I'll see you in another section. Have a nice day.